Hi, I'm Jim DeLeo, Regional Sales Manager for ABICOR Binzel, and today I want to talk to you about fume extraction torches and how they work. The gas metal arc welding process produces a visible smoke that contains harmful metal fume and gas byproducts. Please refer to the OSHA website for more information on the harmful effects of these welding fumes. The general function of a fume extraction torch is to capture the maximum amount of fumes possible without affecting the quality of the weld. When you first look at a fume extraction torch, it might look overly complex, but in actuality it operates much the same way as a standard MIG gun. They include a lot of the same components such as consumables and internal parts, but it has a housing built around the entire torch that captures fumes at the source. Starting at the front end of a fume extraction torch, the first part that's different from a standard MIG gun is generally referred to as the shroud. The shroud is typically located on top or over the nozzle, or sometimes even integrated into the nozzle itself. There are many design options available from different manufacturers, and they're typically made of copper, brass, or nickel-plated copper and brass, and sometimes even steel for higher durability. High flow shrouds are also available for out-of-position welding. These shrouds have a larger opening and sit closer to the weld. Another option are tapered shrouds that allow access to tighter areas while maintaining the proper fume extraction. A tapered shroud wouldn't work as well in out-of-position welding, just as a high flow shroud wouldn't give you the same joint access as a tapered shroud. As far as shroud designs go, no one option is the best. You just need to pick the best one for your application. The neck design of a fume extraction torch includes a standard torch neck surrounded by an outer tube with a gap between the two that's large enough so it doesn't restrict airflow. Neck angles vary slightly between manufacturers, but are generally available between 45 and 60 degrees. This range allows the torch to be in the optimal position for fume extraction while accommodating the natural posture of the welder. The handle is the most restricted part of a fume extraction torch. It's important to maximize the space within the handle while still keeping it comfortable for the welder. Some manufacturers include a swivel or ball joint at the rear of the handle to reduce stress for the welder by allowing the hose and the cable assembly to move independently from the handle itself. The hose is connected to the swivel or ball joint and runs over the power cable to the rear of the torch. Some manufacturers increase the size of the hose towards the rear of the gun to maximize airflow. At the rear of the torch, there is a Y or T connection that connects to a hose that leads to the vacuum system. A Y connection provides a gradual curve for the air to travel through, decreasing its resistance or turbulence, and increases the overall airflow. In order to keep your fume extraction torch running efficiently, you must avoid any loss of vacuum pressure. Regularly check your hose for any openings, cuts, or leaks. Also keep your shroud and the interior of the handle free from any spatter or fume particle buildup that can restrict flow through the torch. It is important to keep the vacuum system clean and maintained. Regularly testing your fume extraction system is also recommended to achieve the desired results. Fume extraction torches are well suited for any application where a regular MIG gun is used. They are not limited to any one application, process, or position. If you have any questions or would like to see a fume extraction torch yourself, contact your area district manager or visit our website, binzel-abicor.com. This is Jim DeLeo. Thank you and have a great day.